So this is a continue of problem 4, practical kinematics 2, and we solve the second part of the problem, which is the relative acceleration of A with respect to B at this instant, and A with respect to B for relative acceleration. So we can start writing the equation A equal to B plus AA relative to B. So AA, acceleration of A, as you can see, there are two components. Keep that in mind. The first one is tangential components, tangent to the path, and the other components, because this is curvilinear motion, so we have another component which is normal and perpendicular to the tangential, and go to the center of the curvature. So that is A and normal component. Here should be point A. And for the B is on the straight line, so rectilinear motion, so only one unknown, only one component of acceleration, which is AB, and the problem also give us is 0.7 meter per second square. And with that, we have all of the information to draw the kinematic diagram. So let's draw the kinematic diagram. At A, curvilinear motion, we have two components. The first one, let's draw with the tangential components. So A tangential components. What is tangential components? It will be there 0.5 meter per second square, and the angle same at the VA, 50 degree from the horizontal. So as you can see there, will be angle here 50 degree. Now the normal components, it always go to the center and have to be perpendicular to the tangential components, and that we have it A normal components. And the normal components, as you know, in the practical kinematics 1, it equal to VA square over rho, and the rho in this case is the radius of this curvature, is 50 meter, as you can see there. So put in, and then the velocity of A, we do it previously 7 meter per second, so we can plug in equal to 7 square over rho 50, so we get 0.98 meter per second square, and AA, it will be 0.5 meter second square, that is already given in the problems. And then we have equal to AB. AB we will show here. The bicycle is here increasing his speed, which means the acceleration same at the direction of the motion, same at the direction of velocity. So go to the right at 0.7 meter per second. So right now, you see AB 0.7 meter per second square. And again, we don't know the two components of A, acceleration A relative to B. So we have it A relative to B, X A relative to B, Y. So as you can see, that process is exactly the same as we do in the previous problem. Also exactly the same we do for the velocity diagram for relative velocity or relative acceleration xy components at is an unknown. So from that we can use to solve for the scalar components. Just before that, we just want to see what is that angle here. There are many ways you can find out. One way is very simple. This is 50 degree for AT. The right angles between AT and AN. So the total 180. So that one have to be 40 degrees to get 180. Or if you go to the finger, you will see something similar. And you can see this is 40 degree given here. It have to be here 40 degree. So that, and you can see with the angles. So let's go back there. We have all the information. So let's write the scalar equation x. And in that case, we have a negative an. So it's 0.98 cosine 40 degrees plus 0.5 cosine 50 equal to AB. Go to the right, so it will be 0.7 positive plus AA relative to B x. So from that one equation, one unknown, I can have AA relative to B x equal to negative 1.129. Similarly, what is negative mean? Opposite to our assumed direction, 1129 meter per second square, go to the left. And then y components, both AN and AT project to the y components, it will be negative. So we have negative. In x component, it's 0.98 cosine 40 degrees. So when you already determine the x component is cosine 40 degrees, the y components, you just close your eyes, write down sine 40 degrees. So make sure you do correct one, and here the close your eye, flip cosine becomes sine, and vice versa. And then you have the other components, x component 0.5 cosine 50 degrees. Then you also have negative 0.5 sine 50 degree, and then equal to AB is horizontal, so the vertical will be 0 plus A relative to B y components. Again, one components, one equation, one unknown, so we can have AA relative to B x equal to negative 1.01 or equal to 1.01 meter per second square. It's negative, so it means going down opposite to our assumed direction on the kinematic diagram. So we have two components. The next step, we need to find out what is the magnitude and the direction. So let's work on the magnitude. So you have AA relative to B, and again it's similar to velocity. When you go up here, just do the square root, because the right angle, as you see, 1.129 square plus 1.01 square, and it should be equal to 1.51 meter per second square. So that is the acceleration. And then we draw the diagram so that you can see, or we can visual what it look like for the direction of this vector AA relative to B. So that one is x component 1.129 meter per second square. The second component, which is y going down, 1.01 meter per second square. So again, and again, it will be the diagonal of this rectangle. So we want to find out this this angle theta there. And this actually that is A A A relative to B, which is 1.51 meter per second square. So let's go theta. So put theta on, invert tangent of opposite 1.01 divided by the adjacent 1.129. Inverse that, we will get 41.9 degrees. So what does that mean? We can have our answer in that case is relative acceleration of bicyclist A with respect to bicyclist B equal to 1.51 meter per second square at 41.9 degree. And in this case, again, counterclockwise from negative, right? Negative x-axis. So that is the answer. So I encourage you always draw a big diagram to see what should be the angles and make sure you answer correctly in there. So with that, we finish the solution for problem 4, and I also encourage you to look at the PDF solution which is already available to check some geometry in this video a little bit different in terms of equation, how we locate the angles a little bit different, but the answer will be the same. So check it out, but don't be confused in terms of the concept of geometries and also trigonometry in here. So with that, we finish this problem.